Hi guys, my name is JJ Khoza. I am back again. We're doing our final topic on analytical geometry. I am talking about the circle. The circle. This is what I'm talking about. A circle. Oh, doesn't look good. My handwriting is bad, but it should be clear, even though it is bad. I know. Okay, so there is a standard form. So we have a Cartesian plane and a circle. The equation of this circle, a circle passing through origin, has got an equation passing through origin with this radius. Okay, so it is x squared plus, this is the radius r, y squared equals to r squared equal to r squared. Okay, right. But what if we have a circle that does not pass at the point of origin? Let us say the circle is here, alright, and the circle goes like this. We have a radius, right? So it means we now have x that deviates by value a. It has moved away from x, the center. It has moved away by a, value a, from x. So you can imagine that as a. It is moved away. It is moved away like this, right? Horizontally. Okay. All squared plus y subtract b all squared equals to r mod v r squared. So it has also moved up. So it has also moved up. You see. So this point is this new point we are talking about, and it moved up by b. So this is b. This is b here. So it has moved up. So that is why you will find a circle like this. So typically you will find that you have x minus 3 all squared plus y minus 2 whole squared is equals to 32. Ah, this 2 looks like a Z. This is not a Z, it's a 2. This is 32. Let me write it nice. A 32. A 32. It means that, okay, let's say, yeah, it means that your graph, your circle, is no longer at the center. No longer at the center. So if it's no longer at the center, how do we interpret this? Okay, let me correct here. I want you to see that this is a 2. I don't want you to be confused. This is 2. Even here is 2, not a Z. This is a 2. Okay. It came back as a Z. Why? Don't want Z. I don't want anything that looks like a Z in place of 2. Let me correct all these Z's. Okay. This is 2. This is 2. This is 2. This is 2. Yeah. And this is 2. Yeah. Okay, it's right now. So what does this mean? It means that the coordinates for this circle, the center, the new center, the center is 3 map 2. Why do you say it's 3 map 2? Simple is algebra. You have x minus 3 all square equals to 0. So you put a square root and you put a square root. You have x minus 3 is equals to 0. Therefore you have x is equals to 3. Similar to y minus 2 all squared equal to 0, you put a square root, you solve for x. So this is how, just wanted to show you how you get these points. So this is the center of your circle. This is the center. Alright. Now I want to show you some few things. This can be shown to you in any form, you see, because remember what happens if you deal with this. If you expand this, you'll find that you have to open 2 brackets, y minus 2, y minus 2, and then you end up with y squared minus 4y plus 4. Here you're going to have x squared minus 6x plus 9 all equals to 32. So you must not say, hey, where is this x squared and this y squared coming from? Remember, algebra, you've got to go back to my lectures and do the algebra. Okay, so you must know how to do this. We did the product formulas. You must do this. That is why I say, if you don't understand algebra at this level, you must go back and do my full algebra series, Algebra Fundamentals Part 1 up to Part 8. Then you are going to match our standards here. Right, so I just explained that you may find that case whereby the equation of a circle is no longer in this form, but is in the form of a quadratic, or you see a trinomial form type of a thing, trinomial of x squared and x and a constant, and also a trinomial of y squared and a y and a constant, all equal to this r squared, that number. Don't be scared if you see that. It's normal. It's just the other way of writing it. However, if you have a question, come back to me. Now I'm going to show you what happens when the circles intersect. If they overlap, because a circle has a radius, and if this circle overlaps with the other circle, we have R1, here we have R2. Okay, so what can we say about these radiuses? These circles, they intersect each other, meaning that the radiuses will also overlap. Now we say the distance between the two circles, it is less than the sum of the radius 1 plus radius 2. Okay, what if these circles just touch each other? No overlapping, but just touching each other. So you have R1 and you have R2. You have radius 2, right? You have a radius 2. Okay, so what can you say about D, the distance between the two circles? It is exactly equal to 1 plus R1 plus R2, the distance between the two circles from center to center. We're talking about center to center distance. And then the third condition is whereby the circles are far apart. There is a space in between. Here is the radius R1, here is the radius R2. Okay, what can you say here? We're saying the distance from center to center is far greater than, greater than the sum of the two radii or radii. Depends on your accents. Okay, so this is it. Okay, and then on the other section we're talking about a radius and a tangent. You also find this in Euclidean geometry. A radius and a tangent. these lines are perpendicular to each other. These lines are perpendicular to each other. These lines. They meet at 90 degrees. Okay? They meet at 90 degrees. This is a tangent. This is a radius. So the gradient of the radius multiplied by the gradient of the tangent must equal to -1. So the gradient of the tangent is equal to -1 over the gradient of the radius. And also the gradient of the radius is equal to 1 over gradient of the tangent. So we spoke about the gradients. I'm no longer going to explain gradients. And you can also find, because here you have a point and a point. So you are going to have point A and point B. So you may have point A and you may have point B. So you can calculate, you can do the equation of these two lines, of the line, you know, the gradient. You can calculate the gradient and you can do whatever you want to do. You've got 2 points. You can determine the equation of a line, of a straight line. You can do whatever you like. And you can also determine the equation of the tangent. Why? You know the gradient. You know the gradient because the gradient of the tangent is equals to 1 over the gradient of the radius. You can calculate it. You have the points. You'll be given points, or you'll be given the gradient. And then the other thing, we also talk about the intersection points, right? Here is your Cartesian plane, and here is the circle, and here is the line. You want to know what are these points? You want to determine point A, you want to determine point B, meaning that you want the corresponding, the coordinates, right? X, XA, YA. You see? So it may happen that you want this. So in this case, you take the equation of a circle together with the equation of a straight line, because with these 2 points, you can determine the equation of this straight line using y minus ya is equals to the gradient of line AB. You would have calculated it into x minus xa. Right, this is it. So this might happen. You also find that you have the equation x minus 3 all squared plus y minus 2 all squared equals to 32 maybe. I'm just guessing. I'm just doing something here to make you see what is it that you are dealing with. That's all. Just want to show you. Let's say this is equal to 32. So you will have here an equation y is equals to, let us say you have an equation y is equals to x minus 4 maybe, you know. So you will take this y and substitute. You'll take this and substitute it in place of y here. But you first have to expand this. Here when you expand, you open 2 brackets. And here, you are also going to open 2 brackets. Equals to 32. Okay. We are going to have x squared minus 6x plus 9. Here is x minus 3, also x minus 3. Here is y minus 2 and y minus 2 plus y squared minus 4y plus 4 equals to 32. And what are you going to do here? You'll group the like terms together, right? So first you need to take this and substitute. Let me show you. You're going to take this and put it here and put it there, you see. And when you put it here, you are going to have a square, so it means you are going to open again these brackets and have x minus 4, x minus 4, and you are going to multiply and get x squared minus 8x plus 16, and then you will also have here 4 into x minus 4, which is going to be 4x minus 16. Then you group the like terms. You now have an equation that has got similar terms. You group the like terms, you combine it, you factorize, or you use a quadratic formula. It's up to you. If you cannot factorize, you get the values for y, for x I mean, and then you take those values, you substitute them here in this linear equation. With the first value of x, you get the corresponding y. You use the second value of x, x2, you get the corresponding y2. Then you will have your points. Are you clear? This is the end of the analytical geometry. The rest is just the manipulation, application of what we have studied. If you don't understand what I've said, please rewind. Click rewind. Guys, please like my video, give me thumbs up, okay? Subscribe so that you can get each and every lesson that I upload. Number 3, use distributive property and share with all your friends, share with all your contacts, so that they can learn mathematics. I want to make mathematics an understandable subject to everybody in the world, internationally. I am taking out this phobia in mathematics. I am making mathematics friendly. It's nice. And mathematics is simple, not easy, simple, because we simplify all the time. Okay guys, cheers.